programming languages and tools used in embedded system. As a first part, we have taken up this topic, programming languages used in the embedded system. Now you may answer, what are the languages that we have used while developing embedded systems in our third year or second year? We have built some small projects, right? What are the languages we have used while making those projects? We have used C or C++, okay? And you all have, all of us are aware of C and C++ and Java also. These are languages used in embedded system. Not only these languages, we also use Python and hardware description languages like Verilog, VHDL. All these languages are commonly used in embedded system, depending on complexity of embedded system you are building and also the application. Now let's begin with C and also C++. C was created early in 70s by this person, Dennis Ritchie, as high-level language, programming language used in Linux operating system. It is high-level language, high-level programming language. At the time, these were the languages which were widely used, that is assembly language, okay? And assembly language, writing programs in assembly language, we all know. For some tasks, you have to write hundreds of lines, 100 lines of code in assembly language. The same thing can be simply done in just 5 or 10 lines, right? That is the beauty of the C and higher level languages. And it is difficult to write programs in low level languages. High level languages are simple to use, simple to learn, and also to program. They are like English language. And after that assembly language, there was another language called B programming language, which was then created to accomplish these tasks with fewer lines of code, but it did not have data types and structures. Okay, assembly language has some demerits, which were later on fixed in this language B, overcome in this language B, and this too has this demerits called it didn't have data types or structures. Now C has all these things, and it started to become popular. That is C. Next one is C++. Now what is C++? What is this C++? C++ began in late 70s by PhD student named Strostrup, who was using programming language called Simula. He was using some other language called Simula. Eventually, he switched to C, which was much faster and allowed low-level programming also. But then this person who was using this language, Simula, began to add features found in Simula to C, and he called it C++. Okay, that's how C++ came into existence. The plus in C indicates an increment. So C++ is not to the foundation of the language. So this how in this slide we can see how C++ came into existence and by whom. Next one is, here we have mentioned the differences between C and C++. The difference between C and C++ is generally that C is a procedural language. C is a procedural language, whereas C++ is a object-oriented language. We call OPS programming or object-oriented language. Learning C or C++ is a great way to get started with embedded system programming. Some say that if you can learn C, you can learn any language. See, all higher level languages are more or less, they follow the same standard or same syntax with little differences. The concept remains same in almost all programming languages. Okay, whether it is C or C++ or Java or whatever. Concept, the conditional statements, loops and all those things, concept remains same. If you know how loops functions, you need not to know the same loop functionality in other programming languages. Okay, the loops functions exactly in the same way. Maybe syntax differ. Okay, we have to learn the syntax when we are learning new language. Okay, that's why here we said if you learn C, if you have learned C, then you can learn any language without much effort or difficulty. So C serves basis for all the programming languages. Let's continue. In the last class, we have started programming languages which are used in embedded systems. And in the process, we have talked about C language and also C++. And we have seen the differences between C and C++. Next one is, there is one language called Rust, which is not known to us. Just as C++ to C, Rust is to C++. How C++ is an extension to C, in the same way Rust is an extension to C++. There is no much difference between C++ and C. All the syntax of C is used in C++, and some other features are added to C, they called it C++. In the same way, Rust is extension of C++. And it has these characteristics. Rust includes algebraic data types, type inferences, and pattern matching, and many other. These are the features which were absent in its previous languages. C, C++, these characteristics were missing, and they added these characteristics and they called it Rust. It is gaining popularity these days. Next one is Python, and you have heard this word Python. It is very popular today. It was as popular as C and C++ and also Java. Python, basically it is not developed to be used in embedded systems, but today embedded systems and also artificial intelligence, neural networks, all these advanced domains are using this Python language because of it's easy to write the code. It is very easy to write the code. It is not following syntax very strictly. You can write the code very easily, and also many libraries are available in Python. You can use those libraries, thereby you don't have to write down your own code. You can directly make use of libraries available in Python and you could complete your project in less time. That is the advantage of using Python. This Python is used in embedded systems, artificial intelligence, and in all these areas. Out of the box, Python might not be as useful for embedded programming as C or C++, but with numerous libraries available, it is easy to implement features that make it just as useful. It is excellent for automating, testing, and collecting and analyzing data. Libraries, if you have used Arduino, we have many libraries available in the Arduino. Okay, if you want to use GSM module, you don't need to sit down and write your own code. there are modules readily available. You can make use of those modules. You can complete your project in less time. The same is true for Python also, right? And we have one embedded system kits called Raspberry Pi, and in the Raspberry Pi they use Python programming for developing the embedded system. In Arduino we use C++, whereas Raspberry Pi uses Python programming to develop the embedded systems. Next one is, these are other type of languages: VHDL, and Verilog. These are not software languages, these are hardware languages. By using these languages, VHDL or Verilog, one can describe the hardware. Means if you write a program using Verilog or VHDL, they cannot be executed in processor. You are not writing the program for processor. It is not that way. If you write a program in Verilog or VHDL, according to the program you have written, an hardware is created. Some hardware is created. It is like by writing program, you are creating hardware, not by making the circuit. Okay. So you don't need circuit designing knowledge. If you have knowledge in Verilog and VHDL, you can create circuits. That is the main aim of these languages. So think FPGA is a blank paper. Generally, these Verilog and VHDL are used in FPGAs and ASIC design process, ASIC designs. In all this, either FPGA or ASIC design, what we are doing is we are building digital circuit. In these FPGAs, what we have is, we have number of lookup tables and so on. If you connect lookup tables in some way, some functionality is accomplished. Okay, if you let's say in FPGA you can design, in FPGA you can design adder circuit. The same FPGA can be used to design a simple processor. The same FPGA can be used to design multiplexers and so on. If you write program in Verilog or VHDL, for example, multiplier program. Okay, if you write a multiplier program in Verilog and if you run that in FPGA, then FPGA chip becomes multiplier circuit. Then it takes two numbers and multiplies and it gives us the result. If you write code, let's say subtractor code, and if you burn that code onto FPGA, now FPGA circuit changes to subtractor. It is no more multiplier. It functions like a subtractor. It subtracts two numbers, and you can do something like this. Okay, that is what is FPGA. In the FPGA, there won't be any processors. You are creating hardware by using these languages, Verilog or VHDL. We use the FPGAs also in embedded systems. See, compared to processors, FPGAs are faster and ASICs are even faster. ASICs are specific integrated circuits. FPGAs are general purpose. Means if you have a FPGA, you can erase the earlier circuit. You can create new circuit. Okay, circuit will be created, not the program. Program means you will have a processor. In that processor, we store the program, and instruction by instruction are executed in the processor. That is not the case with FPGAs. In the FPGAs, this program will not be executed. This program creates hardware in the FPGA, right? That is the main difference between hardware description languages and software languages. Next one is it is again the same thing, Verilog. This slide talks about Verilog and VHDL. So these are the languages which are used in developing the embedded system. Next topic is embedded systems tools. Now let's see what are the tools which are used in the embedded system. Tools means you need certain tools without which you cannot develop the embedded system design. You cannot develop embedded system. Now in that we have the following tools. The first one is compiler. We all know embedded system contains two parts. One is hardware part, which is a microcontroller or microprocessor. You have to write some program for that. That is hardware part. Sorry, software. The other one is hardware. You have to add all the input devices, output devices, and so on. That is the hardware, including the processor, right? So embedded system mainly contains two parts. One is hardware section, other one is software section. See, in the software, we have to write programs so that hardware accomplishes the required task. Now the question is, in what language you should write the programs. The microcontroller understands the program in ones and zeros in binary language or low level language, whereas we are not that accustomed to write the programs in low level language. It is very difficult to write programs in low level language. So it is very easy for us to write the programs in high level language. Okay. And what we do is we write the program in high level language and we use some tools to convert the high level language which is written into a low level language which can be understood by computers or microcontrollers, right? In that process, we use these tools, compiler. This compiler compiles the program, otherwise it translates the code which is written in high level language like C or C++ or Java into low level language, which is understood by our microcontroller or microprocessor. That's what compiler does, right? And also, where do we write the program? Finally, we want the microcontroller to be functioning according to the design, according to the goals, okay? And we are writing the program for the microcontroller, and we cannot write the program directly into the microcontroller because we already said these things in the beginning. Microcontroller doesn't come with keyboard, mouse, and all these things, right? We have to use some thing called host computer. In that host computer, we run editor tools, okay? Editor tools. In that editor tool, we write the program. In the editor, we write the program. For example, C language, Turbo C, we have blue screen. In the blue screen, we write the program in the high level language. Okay, that is also another tool. Okay, editor tool is one tool which are used to write the high level language code. After that is been done, we use compilers to translate that high level language code into low level language code. Okay, and that is written in this slide. The name compiler is primarily used for programs that translate the source code from a high level programming language to a low level language, generally assembly language or machine code. So that is the use of a compiler. Next one is cross compiler. Next one is cross compiler. What is this cross compiler? Cross compiler. See, we don't have a single processor, with the same architecture, there are many processors with different architectures. If you write a program which can be executed in one architecture, may not be executed in another architecture. For example, let's take this. There are two case one. Case one has one architecture where move operation. Of course, move operation is available in all the architectures. Okay. Case one processor is having architecture where move has a opcode, operation code 1001. Let's say. Okay. What is the operation opcode for the move operation 1001? Let's say. Case 2, where case 2 is having another architecture where move operation is having the opcode 1100. 1100. Are you following? There are two architectures, computer architectures or microcontroller architectures. In the first architecture, move operation is having the opcode 1001, whereas architecture 2 is having move opcode 1100. Now, what we are doing is we are using one compiler to compile the code which can be run in case 1 architecture. Means case 1 architecture means if you write C code, in that C code, let's say we have used some move operation, and this compiler, the first compiler, what it does is it translates that high level language code which is move operation into 1001. That's what compiler does, right? Whereas if you use the same compiled code, if you run that compiled code, if you run that executable code in the first architecture, it will run properly and it yields correct results. Now let's see, if you try to run the same code, same executable code which we got after using the first compiler in the second system, where move has a different opcode, not 1001 but 1100. If you try to do so, what happens is it will not run properly. Okay. Second system recognizes move operation as 1100, but in that place we are supplying what? 1001. So it runs, it will not run. Even if it runs completely in a wrong way. Now at this point, these cross compilers help us. Now if you use first compiler, then it translates the code which is suitable for first computer, not for computer with a different architecture. Now by using cross compilers, we can translate a program to low level language which can be executed in a second architecture also. Okay, that is the use of cross compiler. If you use cross compiler for executing the code in second computer, now what they do is they translate move operation into a valid code for the second architecture. Is it clear? That is the use of cross compilers. So let's see what is written. If the compiled program can run on a computer having different CPU or operating system than the computer on which the compiler compiled the program, then that compiler is known as cross compiler. What we have said just now is the actual meaning. Next one, decompiler. Decompiler does what compiler does in opposite way. Okay, decompiler is reverse process of compilation. Means generally compiler compiles the code, means it translates high level language code into low level language code, maybe assembly language, whereas decompiler does the opposite thing. It takes the low level language code and tries to convert that into high level language code. A program that can translate a program from a low level language into a high level language is called a decompiler. Next tool is language converter. Now what is this language converter? Language converter. See, we have not just one high level language, not just C, there are C language, C++, Java, Python, and so on. If in certain platforms, some languages are more useful, more efficient. Okay. So if you write program in one platform, that may not be efficient in another platform. So it is better to write the code in the language in which it is platform efficient. So for that we have language converters. If you are efficient, if you are good at C, then you no need to learn Java. You can use language converters to convert the code which is written in C to Java language. Okay. Let's say there are two platforms. C is efficient in platform 1, whereas Java is efficient in platform 2. If you are working in platform 1, then you can write programs in C language. Suppose if you switch to platform 2, where Java is more efficient, you don't need to learn the Java again. You can use language converters. Just write the program in C language and use these language converters to convert the program written in C to Java. That is the use of these language converters. Language converters avoid learning new languages. Just with one language, you can convert the code to any language you desire. Next one is assemblers. Next, what is the next one? Next tool is assembler. What is the use of this assembler? Assemblers are like compilers, whereas compilers, what compilers do, they translate high level language program into machine code, whereas assemblers, they take assembly language as input and translates that into machine level language. For example, what is the assembly language program? We have mnemonics like move, add, sub, right? This is how assembly language program is written. Okay, by using these mnemonics, we write assembly language program. And still this assembly language program is for us. Okay, these mnemonics are for our understanding. Each mnemonic has unique opcode, right? Only opcode is executed in the processor, right? So there must be somebody to translate this opcode into, not opcode, mnemonic into opcode, and that is done by these assemblers. Okay, assemblers are like compilers, except that they take assembly language and convert that into machine level language, right? That is the use of these assemblers. Let's read out. An assembler is a program that takes basic computer instructions called as assembly language and converts them into a pattern of bits that the computer's processor can use to perform its basic operations. An assembler creates object code by translating assembly instructions to symbolic names. There is some mistake here. To memory locations. Assembly language uses mnemonic to represent each low level machine code, machine operation. Right? These are the assembly languages, assemblers. Next one is simulators. Now what is the use of simulator? See, in the simulators, what is simulator? Here a machine designed to provide a realistic imitation of the controls and operations of a vehicle, aircraft, or other complex system used for training purposes. These simulators are used for training. For example, if you want to learn piloting, okay, if you want to become a pilot, you are not directly taken to aeroplane and given training there, right? You will be taken to a room. In that room, you will find all the tools which are present in the aeroplane cockpit. Okay, but that room is not aeroplane cockpit room. It mimics the aeroplane cockpit in most way. Okay, 90% you won't find much difference between the aeroplane cockpit room and the room that where you take the training in the beginning days, right? Once you are familiar, once you learn the all the piloting skills, then you will be given a real aeroplane. That's what the use of simulators. Simulators means if you wrongly use the airplane in the training, if you are directly taken to airplane and if you wrongly steer the controls, then you may get into danger of collapsing the aeroplane. So such things are avoided in the simulators. If you wrongly drive the airplane in the simulator room, nothing will happen, right? So simulators is just a virtual thing which mimics the actual one. So we have simulators in embedded system also, embedded system design process also, embedded system design also. There we have software. Simulator in embedded system is basically a software. Okay, we have all the virtual components. For example, we have some understanding of, some experience of what in the basic electronics, in the second year course, we have used some simulators. What are those simulators? We have some components at the sides, we drag them and we construct the circuit. What is that software? One of you, please tell me that software. Multisim. Yes, multisim, right? Multisim is like a simulator. It is simulator for the EDC lab, right? What all you find in the EDC lab, these are actual components, real components. In the EDC lab, we have real resistor, real capacitor, real transistor, real power supply, real oscilloscope, and all these things. Whereas in what is that software? Huh? What is that software? Okay, that is the software. Multisim. I am forgetting this again and again. Multisim. In this multisim, it is simulator actually. In this multisim, we have all the virtual components. You may find virtual resistor. Virtual means not real. Virtual resistor, virtual capacitor, and all those things. If you construct, you can drag all these components which are available at the sides, and you can connect those components and make some circuit, and you can simulate, you can run that circuit in that simulator, and you can find the results. You can see the results. The results which you get in the simulator are very close to the results that you get in the EDC lab, and there are differences, but you can see whether the circuit is producing correct results or not. Okay, so we can use simulators in embedded system also. For that we have Proteus software and other softwares. Proteus is for digital systems. Okay, if you want to build embedded systems, then you can use Proteus software, right? In the Proteus software we have all the microcontrollers, microprocessors, and so on, like 8051 microcontroller, or Atmega microcontroller, or this Arduino microcontroller, virtual processors. You can drag those processors, you can connect some LEDs, some push buttons, and so on. You can run you can write the program in the Proteus software. You can run it and see how you are getting the results in the simulators. Once we are familiar with these simulators, we can use, now we can go to real hardware section and develop your embedded project there, right? That is the simulator, right? Code that is tested for microcontroller unit or system by simulating it on the host computer. Generally we run these softwares, simulator softwares, in the host computer. can be used to code development. Simulators try to model the behavior of the complete microcontroller in software. Okay. Next one is functions of simulators. Now, what are the functions are there with simulators? It defines the processor or processing device family as well as its various versions for the target system. Now, we have many versions in microcontrollers. We have a small version, large version, and so on, so on. All versions are available in the simulators. You can use the versions and simulate the program, whether this program is can be executed, is it properly executing in the lower versions or higher versions, and so on, so on. You can verify it. So simulators have all versions of target devices, like all versions of target device means all versions of embedded processors. Monitors the detailed information of a source code part which labels and symbolic arguments as the execution goes on from each single step. So you can see what is happening with each and every step of a program. Now you may you write the program in the simulator, okay, by using C or C++ or Java or Python, and you execute that code, and at the end you realize there is something wrong. Means the code is not executing the way you want it to execute. Now, how do you correct the code? Now you go to every line. You know what you have written that line, and see whether that line is getting the required results or not. So you can go to each step and see whether it is working properly or not. So that is what this line is saying. Next one is, see, simulators have some ports. Okay, if you open some window, in that window you can see how each when you execute the first line, what are the means in the processor, what we have, when every line is executed, there are some changes taking place in the processor registers. We have so many registers in the processor, like A register, B register, or R1 register, R2 register, and so on, so on. There are so many registers and also counters, right? So we have so many registers and counters present in the processor. If you want to know what values they are getting and how actually the program is executing, and if there are any subtle bugs, you can look at these registers and you can find out how you can find out those bugs and you can correct them, right? So for that reason, you can see there is provision here in the simulators. There will be provision. By using that, you can see what is happening in the registers, okay, either in control registers or system registers, or and also in counters. So we have that option also. Next one is provides trace of the output contents, program counters versus process registers. Means the same thing just now what we have said. And in the simulators, you can place breakpoints and also stop points. Breakpoints means, suppose you have some doubt in 20th line, whether 20th line is running, giving us means if you are a beginner, then by using these starter kits, one can develop embedded system very quickly. You can learn it very easily, and also you can develop embedded system projects very quickly. That is the use of these microcontroller starter kits. What are the starter kits available? We have Arduino is one starter kit which is very popular, right? It has the following units. Starter kits comes with hardware board, evaluation board. Our Arduino board itself is this one, okay? In-system programmer. In-system programmer means generally how we program the microcontroller, we have to use separate programmer. We have to use separate programmer for programming the microcontroller. Whereas if we use these starter kits, that programmer is present within the starter kit. You don't need, if you have Arduino board, you don't need anything else, something called programmer for programming the microcontroller present in the Arduino board. You don't need separate one. It comes with in system programmer, means it is present within the Arduino board. You don't need any separate programmer for programming the Arduino board, right? It has in system programmer. That is not the case if you use a separate microcontroller. If you use a separate microcontroller like Atmega 328 or Atmega 8 or Atmega 16, you need a separate programmer. That is not the case with these starter kits, right? Not just with Arduino, any starter kits, they all have in system programmers, right? And see some software tools like compiler, assemblers, linkers, and so on, so on. You need all these tools like editor tool, compiler tool. Editor tool is used to write the program in high-level language. Compiler tool is used to translate that high-level language code into low-level language code, and linkers to combine all the modules, and so on, so on. We need all these tools to develop the embedded project. But if you use this IDE is called integrated development environments. IDE is called integrated development environment. It contains all the tools that are necessary to develop embedded project. For example, Arduino is one IDE. Arduino contains editor, that screen where you write the code, that is editor, and Arduino has its own compiler, its assemblers, and so on, so on. So if you install IDE, integrated development environment, you don't need to install compiler, assemblers, editors separately. Just one IDE is enough to develop the embedded project, right? That is the use of microcontroller starter kits. A big advantage of these kits over simulators is that they work in real time, means it is actual hardware kit. It is not a simulation, means you are working directly with the hardware components, and thus allow for easy input-output functionality verification. Starter kits, however, are completely sufficient and the cheapest option to develop simple microcontroller projects. You can use them in the beginning stage. If you are designing high-end projects, then this may not be sufficient. Next one is, we have missed one topic called timers that we will see now. What is timer? Timer is a circuit which provides time reference in the processor, in the microcontroller, right? So now you have written some programs like delay functions. You have used delay functions in Arduino and other softwares. So in the delay function, what delay function does? It stops the program execution for a while. Let's say if you are using delay of 15, means you are using delay 15 seconds or 15 milliseconds like that, right? Means it stops the execution of the program for 15 milliseconds or so. How do you get this time reference 15 milliseconds or 10 milliseconds and so on, so on? That is possible with hardware called timer. Timer is a hardware which is present in the microcontroller, same IC. Okay, it is counter. It is basically a counter. It takes the clock pulses which are coming from the clock generation unit, and it starts counting those clock pulses. If your clock is 1 megahertz clock, then each clock, each pulse, let's say each clock duration has how much time? 1 millisecond. So it's this counter, this circuit called timer. Timer is hardware which is present in the microcontroller, right? It receives the clock pulses from the clock. It receives the clock signal from the clock generation unit, and it counts those clock pulses. Let's say the frequency of the clock, incoming clock, is 1 megahertz. Means what is the duration of one time period? What is the duration of one signal, 1 unit of signal here, 1 microsecond. So that counting circuit, it counts those incoming clock, and the results are updated in the registers. Okay, every timer has some registers. It may be a 8-bit register or 16-bit register or 32-bit register, depending on whether the timer is a 8-bit timer or 16-bit timer or 32-bit timers. We have timers, variety of timers. Okay, we have 8-bit timers, 16-bit timers, 32-bit timers, and so on. And if we are using 8-bit timer, let's say every microsecond, for every microsecond, the register is updated, register is incremented. Generally, the counted values are updated in the registers. In the beginning, when there is no incoming clock signal, register has values, all zeros. After receiving the first clock, means after 1 microsecond, the register is incremented to 1. After receiving another clock, means after another microsecond, the register is incremented to 1, 1 0 0 0 1 1 0 1 1, and so on so on. It increments upon receiving the clock pulses. Okay, that is what is timer. Timer comes like 8-bit timers, 16-bit timers, or 32-bit timers, and so on and so on. And your microcontroller may have a single timer or 2 timers or 8 timers, and so on. Each timer unit, let's say your microcontroller is having 8 timers, means it has 8 separate hardware blocks. And also timers, one important concept associated with timers is prescaler. Prescaler, by using prescalers, you can increase the time period at which the timer counts. You may not need the highest resolution all the time. You may not need to count in the microsecond resolution. In that level, you need to count only seconds time. Okay, those times what you can do is you can divide the incoming oscillations by 8 or 12 or 255 or something like that. And so if you divide the incoming frequency 1 megahertz to 12, what happens is the resultant frequency goes down. So your resolution of the timer decreases. So you can count to seconds and so on, right? That is the use of these prescalers. You can set these prescalers to 12 or 8 or 255, something like that. For that, we have control registers. There are some, see, every timer, for that matter, every peripheral, timer is one peripheral. Every peripheral comes with some control registers and some general purpose registers, right? By writing 1 or zeros in some locations, you can change the division value here. You can change the division to 8 or 12 or 256 or 55, something like that, right? And for that, you need to refer the data sheets. And in this course, we use microcontrollers. There we will talk about timers in a detailed way. Now, this is the timers for now. Okay. Basically, timer is a hardware which takes the clock pulses, means clock like this, and it counts those clock pulses. It generally timer is not on. You have to turn on the timer depending on your requirement. Generally, it is in off state. You have